Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night, of course. One day we won't have to do that anymore. And then what will we do? Something different, that's what. You can go to certain.z.dev to learn more about the project. Yesterday, we were working on the clouds in the clock tower, and just as a reminder, let's see if this works. No, of course it doesn't. Give me 1 second. I'll get it working. Just as a reminder of what that looked like. One cheat is enabled and that may crash the games. Oh, no wonder it's not working. Controller's not even on. And of course, it's not working. Give me 1 second. I'll fix this. All right. Are we working out? Yeah, we are. All right. Just a reminder, here are the clouds. They kind of track with the camera. Can we see more of them if we go up higher? Not really. They're always kind of in that same place in the viewport, regardless of where we are. Interesting that the background doesn't scroll either. I mean, it scrolls with the player, but there's no parallax. If anything, no, yeah, the moon stays vertically where it is. But these clouds, they're kind of wispy, they're in their own layer, and there's some math that's going to go into getting them to warp and distort the way that they are. So that's what we're working on, in case you forgot or didn't watch yesterday. That's okay. I'm glad to have you here if you're watching today. Thanks for joining Twitch, YouTube, checking out the replays. So let's get back into that. There's we're working on both the PSP and PlayStation versions of the game. The PSP I think is going to be a little easier, so we're going to keep working on that. Oh, and I hope this saved my progress from yesterday. 21 hours. Let's see where we are. So the PlayStation was not saved, so we're a little further on the PSP. Let's make sure that gets saved. So one of the things that I mentioned yesterday is that some of this uses the scratch pad, and the scratch pad is a place on the PlayStation and PSP CPU that has basically fast memory access. It doesn't have to go to RAM. It's something embedded on the chip itself. Usually this, on most MIPS CPUs, this is used for like an instruction cache, but in this case, it's not. And we have macros for this, and I'll have to make sure that my macros are up to date in the context, but I thought that would be good to look at as well, and see how this is typically accessed. What's interesting about this, and I tried to do this a couple different ways yesterday, and I might try again today, but this address, typically when at the C programming level, as opposed to like the machine code level, when I see an address like this, I usually think, well, I should just be able to replace that with a symbol, and then at link time we can do this. But for reasons that I'm not quite sure yet, I was having some trouble doing that, and we'll have to figure out why that might be. One thing I noticed here. So these scratch pad and spad macros, they previously were in common.h and game.h. That means every file has access to those, including the assembly files. I didn't think that was very critical, so I actually just move those out into their own header file. And that means when we change them, I can rebuild 196 parts of the dependency graph instead of all these 3,000 or whatever would be required otherwise. But anyway, these are the macros. The major difference between the PSP and the PlayStation is just where these exist in memory. So not a huge difference. That will affect a bit. So I'm going to update these and make sure that I have the current ones in here so that we are getting the right thing. Make sure that the SP version of this points to the right address for the PSP. And is there anything else I want to do? So the spad macro. Interesting idea. Oh, Roaming, you're so smart. Roaming on YouTube, you guys can't see the YouTube comments if you're on Twitch, but I'll tell you what he said, and he had a super insightful take on this. So I didn't even think about it. So the structure of this address, I think, is important. Man. I'm going to fix this macro real fast, and then I'll go over why. And we'll look at where this is. So let's go to one of these places where we have the SP, or the scratchpad address here on 98. And we'll go find where this instruction is. And of course it's not there. Let's find the first reference to it. Why don't I have a reference on 98? Here, so on 99, we actually see the reference to it. But look at this instruction. So if I made this a symbol, and I really wanted to make it a symbol, so I really wanted to make it a void star, and we'll call it scratchpad. And here is, going again, our instruction is load upper immediate for register S6 1F80. Where else is F6 getting loaded? Nowhere. And if we look at this, what are we adding? The low part of this 1F80 instruction, or address, which is 8 bytes into that scratchpad offset. If I change this to G scratchpad, what's going to happen? Roaming is exactly right. We get 2 instructions. Why do we get 2 instructions? Because at compile time, we don't know what the value of that symbol is, and the compiler can't know what it is because we've used indirection to hide it. And so it needs to fill in all 4 bytes, and it can only do that 2 bytes at a time, so it requires 2 instructions. I was banging my head over this yesterday. Why is this so different? Why is this so different? But that's exactly why. Thank you, Roaming. Too smart. Too smart. So we have to use the constant, because the constant at the bottom is 0. And so when we load that, we only have to load the upper part of that 32-bit value. We don't have to load the lower part of it. Crazy. All right, so let's go back over here. We're going to use the SP and spad macros and try to get those to work as well. And let's see where we were. Go right over here around 119. So I'm going to start with spad 0, and I would expect to get the right instruction, but we're not... We see this much further down, going into the S2 register. So let's try it down here. And get rid of Cloud Scratch altogether. Here it actually looks like we might be a little low. So here we're close. Let's try just the SP macro. We do SP0. Oh, the issue is we're going to the stack. All right, let's back this up a little bit, and we're gonna go through and clean up some variables. We have way too many variables that's screwing up the stack, and so we're getting a lot of extra instructions that aren't necessary. So let's clean this up, and then we'll move on, and hopefully the cleaner stack will enlighten us as to where these things should go. We'll get rid of that one yet. Let's look at, I'm gonna cheat and look at the decomp. So if we're reading this into a variable, it's happening down here. Not sure yet if that is being read into a variable. Then Roaming says, MetroWorks allows you to declare a variable like int a at a specific address. Interesting. That notation conflicts with the bit field notation. Can you declare a bit field outside of a struct? Maybe not, so maybe it doesn't conflict then. Huh, that's interesting. Let's see if we got rid of this RS5. RS0, I almost wonder if that could be I as well. Let's look at that. 63, we're going to check out what register is being used. It's going back to the stack pointer, offset 30 on the stack pointer. So we can still use that. So it's S0 in the original, offset 30. Let's go down here where we have our I. And that's S0 as well. So yeah, this one can be I. So this looks like it could be 12 minus I times 3. Let's see if there's a sub in here. There is. It's not quite what I want, though. Come back to it. Yeah, a bunch of this is just a mess. All right, so let's work through this inner loop first, and then we'll go back and try to clean up some more. Oh, so this is interesting, and this actually makes a little more sense with the subtraction. So I originally sorry, wheels. So GCC had this as a subtraction in the for loop, and usually when it's like that, it seems to be some type of GCC optimization. It's not common to go from a high value to a greater than 0. And so usually I rewrite them and it's fine, everything works out. But in this case, it does look like they started with 4 and subtracted. And I think that's because of the way the math is going to work out. And so we'll see that in a second. I am going to set this. So we'll use var v1, and again treat it as an array. And I think the way that we were doing that is by using a reference and then dereferencing again. I'm not sure if that's going to be what's necessary, but we'll go with that for now. And it possibly is I as our index. Let's find that instruction. Yeah. So our angle here, that may be it's like that's being added to at the bottom or near the bottom. So we have a few things with so first with this multiplication, we're getting masking, which means varfp is probably the wrong type. So we'll make that assign 32. VARFP, the reference there is that it's using the FP register. Not likely that it's using the FP register. And this 1C0 addition is happening at the end. Var S5 should be assigned 32. I'm at the wrong offset here. We're shifting by 16. So there must be a multiplication that I'm missing. Varus 2 looks like it doesn't exist. And it looks like there is a multiply by 3 here. Let me work this out. Varus 2. No, so that's this assignment. And Varus 4 coincidentally is the same variable being used. Varus 4 is, yeah, and this should be obvious. It looks like temp low is not a separate variable, which makes sense. It can be used by the compiler when doing various conversions, and so that makes sense that it wouldn't be its own thing, and getting rid of it only helps us. So we're calling var s5. M2C right now is calling var s6_2, and that's fine. And var s5 is our var fp. So we're missing a, looks like RS0, which is our I. So we're missing an I times 3 here. I think that's all. So VARS2 here, this will go away now, because all this is being done by I. And we do need to subtract. So it's while we're greater or equal to 0, I minus plus. And RS2 is our var v1, and that is offset 5, and we'll say offset 5, 0 to keep the convention the same. And I'll have to go back and look and see. So this looks like still Virus 2 being used, or var v1. So I think that's fine, and then we're resetting it for reasons I don't know again. So Virus 2 is never, it's always used as a pointer, it's never mutated, but we keep resetting it back to the stack point, or the scratch pad, sorry. SP, I think, stack pointer. And again, this could be, I'm using it as an array of arrays, but it could be a struct of arrays, or it could be an array of like fixed arrays. That'd be fine. Hey, does it? Good to have you back. But this is getting us closer, and so our stack actually, we're almost there. Let's go clean up some of these. Our FP we still have. Do we have a good idea yet? So there's two angles, basically, and if we go back and look at what the clouds look like, I think this is the deformation of, there's like a hump or a bulge. Oh, my controller. Shoot. There we go. So we kind of have a wave that goes over and maybe slightly vertical as well. So for you, that would be like this. Definitely one that's kind of pushing it up. But then I think it's getting compressed horizontally as well. So I think we have those two competing angles. And so that's what the 84 and 86 are. So I'm going to rename angle here. I don't know which one's X and which one's Y. I'm just going to call angle X, guessing that it is coming first. And then var FP we can call angle Y. And that makes those names a little nicer to read. Var S5 here, that'd be nice to have a better name for. But that also gives us an idea of what these entity extension names might be as well. And change this to a minus equals here. All right, so let's see what other variables we can get rid of. Virus 4 seems necessary to keep around at the moment. Virus 1, I think that's gone. What I might do here is make this a collection of arrays, and we can try it again in a little bit. I'm not going to do it quite yet. So we have offset 5, 10, and 15. There's offset 20 as well. So this will be 1, 4, 1C. No, probably not 1C, right? 14. Yeah, it would be no. 1E, but I thought we had one more. Oh, the 20 comes from the offset there. So I we'll come back and try to do that later. All right, so let's see if there's anything else that's obvious. A extra sign extension here. So this actually looks like it is getting assigned to a variable and then getting assigned here. So we need something. This uses S0, which I think was I. Oh no, sorry, it uses V1. It does the shift twice, which is why I didn't. So yeah, I don't think that's right. Not sure where the second sign extension is coming from. Oh, what is I? That's going to screw up a lot of things if I change it to a sign 16. But I can't do that yet. I just saw my other error. I need to get rid of this cloud scratch. So we can do this. We could do unknown 0, 0. And see if that works, but we'll come back to that. All right, so somewhere along the way that worked itself out. Okay, I'm fine with that. 55. The add is happening before the prim next. I guess that makes sense, because usually what's driving these primitive lists, iterating through the primitive list, is the prim next, and I just happens to be used here as a temporary variable, kind of tracking not even the index, but a modded version of the index. So I guess that's fine. 61, this looks like ordering. We're missing a read. Is it this? Nope, not that read. I'm going to go look at the entity extension. I don't remember the types that I have for any of these. So we're reading self back from the stack. Oh, this is a pointer. Interesting. Okay, so this looks like a pointer at offset 80. No, it's not. It's not a pointer. It looks like a 32-bit value. And that's not the structure that we have otherwise. So let's add a... And hopefully these are the same between the two. That probably will break something else, but we'll deal with that as we need to. 66. This unknown 82. 82 is actually 84, so I'm off by 1 anyway. It may be that this is a fixed 32. Let's do that and see. And so 66 unknown 82 would be unknown 80 dot high. So this is probably a fixed value then. So we can say that this is fixed 1.5. And we're just mucking with the integer portion then. So we're doing the minus equals 80 first. And then we have a sign. Why do we have this sign extension? We don't see that elsewhere. It's almost like this is being reassigned back to Varus 5. What the heck? Let's try this. So why did it work? Or did it not work? Did I have register issues? I see. I had register issues. Okay. So yeah, we have this odd pass-through assignment for its own field there. Strange. So for the most part, I've gotten rid of this cloud scratch. You want to look down here, though, on 96 and see if this worked out. It didn't work out the way that I wanted. So we're just going to get rid of that. And stick with the var v1. That didn't work out quite right either. Try a couple different things there. We do. I see. I see what's going on. Do I see what's going on? So we're loading var v1 again. That's this load, putting it into register S2. Where's the plus, or where's the load coming from here? Oh, this is just a branch I see. So this looks like it could be a do while loop. Go down and see what M2C did write this the same way. We know though that we just set this up here. Oh, what about that? Did I just have a semicolon in the wrong place? That was what I had. Here it does look like we are adding. I was wondering why varv1 wasn't changing. I think these are going to end up being the same thing. So this says add to S2 the value of S2 plus the low 4 bytes. Sorry, low 2 bytes, low 16 bits of this symbol's value, which is 1014. And so that just gives you the 14. And so here I'm adding hex 14. I think that's going to work out to be the same thing. And so throughout this, it might be worth making a type def of size 5, an array of size 5, 16 ints, and then putting that in place. And then some of these things can be indexed more appropriately. Dizik said several minutes ago, and I just missed it, but seeing it now. Can this value up here, could this be a 0.16? And so we have an XY value stored in 32 bits, but 16 of them are for X and 16 of them are for Y, and then being stored at once. If this was GCC, I would say yes, absolutely, but it's not. So we could try a few different things. I don't think that MetroWorks would do that, and so we could try it here and see. So if I said 1 and X 8000, the scale of the two values is a little strange too. Fortunately, because the optimizer's not on, this will this should work. And so what like if we're assigning it all together, so GCC would say, oh, that's 32 bits, I'm going to construct a 32-bit immediate value from this and just assign it as a 32-bit value. MetroWorks doesn't do that. And so we could try to do it a bunch of different ways. This val kind of forces that, so taking the two 16-bit parts and assigning them together. Because that's how the code gets generated, I'm pretty sure that that's what it is. I can't recall seeing any case where we had something like a 0.16 that's assigned with both values together as a single immediate. But it happens quite a bit with those Konami fixed point numbers. I'm going to take this and see how we're doing on the PlayStation. I do need to update the entity extension. Yeah, I'm sure if we turn on the optimizer, we could get the same type of code. We're at 93% over here, not too shabby. An unsigned versus a signed assignment on 74, so unknown 84 probably is unsigned. And that fixes that. Some funniness down there. Let's make that same change over on the PSP. Oh, bummer. It doesn't work over here. Drat. So I think in F32 both are signed, but maybe low is not. Low wouldn't have to be signed, and it doesn't really make sense for low to be signed. It makes much more sense for it to be unsigned. Since it's just the fractional portion, it can't have a sign anyway. I wonder how much would that break everything to change low to unsigned? Probably tragically. But if it were, that... No, it still wouldn't work because I have this as unsigned. Let's look at where that is. It's this here. Let's unknown 84. And it's just a simple addition. Not sure why it would be one way. But we will just make it conditional for the moment. And I'll so same thing we see here. We're taking the low parts of this symbol, and that ends up just being the 14, and so we're adding 14 here. Okay, how's our stack? Still too much on the stack. I'm going to go back up again and see what might be going on. Prim index should be assigned 32. Does that help us? Not enough. So Cloud Scratch ends up not being used again, so I'm going to get rid of that. 76, we have a sign extension, var S4, so it should be assigned 32. That probably cleans things up quite a bit. 80. We're missing a sign extension the other way, so the argument angle Y looks like maybe that should be 16-bit. That would go along with the other one. What is this? So it looks like we're getting like an extra multiply. So if we shift right 12, so is this times 4? I'm trying to counteract, so fix to I changes the PlayStation format to an integer. So we're shifting off 12 bits, but this says that we're actually shifting off 16 bits. Oh, because I'm using the wrong one. It should be float to I. That's right. Better. And that has us actually almost there. Maybe even very close. 107. Looks like here there's a var v1 plus equals 5 times size of S16 again. Register S0 is what? Prim? Oh. We're missing a prim next. That would be a bad loop. We're getting really close. This actually might be it. 126. This is the debug code. The buttons are different, so the immediate values are different there. I think that might be it. That could be it. We have... Yep, that's an immediate... Okay. Come on, PlayStation, you can do it. Okay, so I think we're going to have the same type of issues here. GAPI symbol, no big deal there. Again, the low macro or low... I don't know what data type this is. Notation in the assembly takes the lower 8 bits. Maybe it's a macro, because it's not part of the assembly language. It happens beforehand. It just takes the lower 8 bits. Sorry, lower 16 bits. And so that would equal 8. Likewise. Same for these two. And then just immediate value. So I think this works. So we need to go do the entity extension work first. I'm just going to throw this in here the way that it is, and I'll fix it later. And see if there's any while that's going. Okay, so I think all that's there. The only thing that I think I would change, and I probably don't have enough time to go through it all, is just to see whether or not changing var S1 or var v1. Let's try it and see if... So GCC should be a little more tolerant of this change. And let's see which... where do I want to do it? Let's try it here, I guess. So I have to make sure that I'm using the same variable, but what I want to see is, are we getting the same... Cloud cache sounds like something way too modern for this. Are we going to get the same instructions? So I'm going to... try to get rid of this carefully. Drat, that's not what I wanted. 10 is going to be 14, I think. 5 is going to be OA. And 15 is going to be 1E. So there's some issues with the variables here, but the rest of it worked out actually pretty well. This is the bigger issue, is then we're shifting this by an odd value. So it is like it's an array of 5s. So we could do that. So it's not that cloud cache struct. It does look like it's probably an array of sets of 5. And I guess that makes sense because, again, we have like this wave motion and it's repeating. And so this probably is a calculations for a table for how that deformation happens. All right, so let me undo that, get back to something that's working. Just finish compiling. I have this open somewhere else. That's okay. Uh-oh, what did I do? What did I do? All right, that worked. And there's nothing in here that's too special. So I think this should work on the PSP as well. It didn't. Let's build it again. I didn't pay attention to compiler errors. Did we get anything? No. Oh, roaming says PlayStation worked fine with the Sign 16. I should have checked that. Awesome. That's great. So I'm getting something wrong though here. Yeah, and that happens with the optimizer. Sometimes when you don't have things, what did I do? or you don't have things quite working, the optimizations will be different enough from when you finish your optimizations. Let me just make sure that these are both the same. So there's still something going on. The issue, it's not a huge issue, I think. I think the issue is that this is generating RO data, and I don't have that mapped properly. That's my guess. So I'll muck around with this and try to fix it, but that's my guess, is that that didn't get mapped in properly, and once that gets done, it should work. But until then, I will leave it the way that it is. So that's all the time I got. Go to soten.z.dev. Thanks to Zik and Roaming. And let me know if there's anything you want to know or see in the future, and I will try to address it. But that's all the time I got. Adios.